the recording seems to be working. Good. So let's try to start with the subject of the identification. And this lecture is relatively cartoon, brief overview, a lot of pictures, no mathematical formulas whatsoever. We will basically look at how our world works at the moment, how it used to work, and what changed. Why should we look at the subject of system identification? I guess I had this slide already showing you for our modeling in process industry class, but yeah, maybe we will dive a bit deeper to it today. So the first message, I really like this graphic. The first message is that our world is really accelerating. Everything is happening faster and faster. So our agricultural revolution, which means that we as a mankind stopped wandering around the earth, and we settled down somewhere where we had the field with our crops, with the vegetables, fruits, and so on, happened at some point, and it took 8,000 years until the industrial revolution, where we realized we can divide the jobs in the society, that we can make some jobs even somehow automated or at least mechanized, like so we can use steam engine, we can use some engines to help us in our world. Then from the Industrial Revolution to the invention of a light bulb, only 120 years passed. Between the invention of light bulb and moon landing, there is only 90 years, 20 years from moon landing to the World Wide Web, and 9 years to the sequencing of human genome. It's completely arbitrary, these events, but they are big events in the human history. The interesting part is that this gap is really shortening, and we are speeding up in the development. And the speed up in the development in the 20th and 21st century was also observed in something which is called Moore's law. Did you hear about Moore's law before? Moorov zákon in Slovak. There was Mr. Moore. Marek is nodding. Marek, did you hear that about Moore's law?
I just saw the picture.
Uh-huh. Do you remember something about that?
Not really, no.
Okay, and if you would have to guess, what would you guess?
About how technology is advancing more and more rapidly.
Mm-hmm, mm-hmm, yeah. And the concrete example is that Mr. Moore was an engineer in, I think, Bell Laboratories in US, and what he observed, well, he did a data-based observation. He took some data. He took a time axis, and he marked several points, and these points represented the number of now I have to find the correct number. What was it? The number of transistors? The number of transistors on the different computer processors, or nowadays maybe we would say on the chips. So basically how much computing power does a processor hold? And he drawn this data. And he found out that roughly each 10 years the number of the transistors is doubling. What does it mean if something is doubling? What kind of growth is it? Is it a linear growth, quadratic growth, logarithmic growth, exponential growth, or anything else? What do you think? Exponential, right? Because that's the standard example. The first example of the exponential growth is some story about a Shah in Iran or a Persia who was playing chess with one of his workers, servants, and he lost in the game of chess, and he said, he asked the servant what he wants for as an award for the victory, and the servant said, okay, I will put 1 grain of rice on the first square of the chessboard. Then I want you to put 2 grains of rice on the next what is it, piece of a chessboard, and then you will be doubling. Yeah. So do you have 2 grains of rice on the second? What is the word? Now I'm missing the word. What is the word políčko in English? Huh? Slot. Slot is good. There is something. Rastya plays chess. Field? No. Square. Yeah, square is the correct one. Or sounds good. So on the third square there are 4 grains of rice. On the fourth square there are 8 grains of rice, and it's doubling. And when you reach the end, so 2 to the power of 64 grains of rice, you basically have the same amount of grain of rice as the number of atoms in the universe, or even more than that. So it's quite scary. And how actually does this plot work? If you look here on the y-axis, it's actually not a linear scale. It's actually logarithmic. So one movement, one step in this direction doesn't mean like adding, like 1, 2, 3, 4, 5, 6. Doesn't mean like adding the same amount of numbers, but it's adding the number of powers of 10. Yeah, so we can easily see it here. The one step corresponds to increasing the scale by 10 to the 5. So by 100,000. Yeah, so. Increase by 100,000, increase by 100,000, increase by 100,000, change of 100,000. Here it's even better visible from 1 to 100,000. So already this plot is showing if we got a straight line, that's already an exponential growth, but this is what Mr. Moore observed, and later, with the farther evolution, we actually saw that this Moore's law is getting even violated, and we are seeing even more rapid development and even higher number of the higher number of now I forgot the word. Transistors on a chip. You see that I'm not a hardware guy, so that's why I cannot remember these hardware terms. Prediction was this graph is from 2011. I just like the graphics, that's why I keep on having it, that we will reach the singularity at some point. We will surpass in 2023 the computing power of a PC, of a chip will surpass the human brain. Maybe we are somewhere around that. The same trend, in slightly different numbers, is actually happening with the number of data. Yeah, that's what I was trying to tell you in the beginning. Cheap sensors, more available sensors, more reliable sensors give rise to more sensing capacity. We can sense more data. We can store more data with a much smaller price. And well, now we have a problem that we need to make a sense of data. The world is extremely rich with the data. And now this will be Slovak and English combo with because I took some news. this is maybe from 2022, where they say that the prices of the breeds of dogs rapidly changed during the COVID pandemics in UK, in Great Britain. Nice, right? Why was this? Why did it happen that the prices of the dogs, of the different breeds, increased? What did I do? Better.
The demand rise.
Hmm?
The demand rise.
I cannot hear or cannot understand. Once again.
The demand to own a dog.
Yes. Why did the demand rise?
Because I believe during the pandemic, only people with dogs were allowed to go outside.
Exactly, very good. And also we were alone, stuck at our homes, and we wanted to have some friends along. Exactly, yeah. So very important thing. The data doesn't tell us what happened. Yeah, they are just sitting in some database usually. It's a good thing to plot them, to actually have some kind of overview, some statistics, but some at least basic statistics. But to make sense out of data, that's a much harder problem. It's nowhere shown. What happened here? So we have the same photo from some satellite, which can actually show the nitrogen dioxide levels in China in January 2020, and the same measurements in February 2020. The nitrogen dioxide levels are much lower. What happened? Yeah, factory shut down because of the COVID-19 pandemic. Yeah, I use the COVID-19 pandemic a lot in this lecture because it's a great source of the data. You can think of it as it was really you did with your Flexi device the step change in some input. It was a step change in many inputs in the world. Yeah. Another one, we can see a big step change also happening around March 2020. There are fossil fuel prices, so some oil, some naphtha, natural gas. There is even coal. So the question would be, yeah, if I can predict what is going to happen. Let's say I'm in January 2020, and I already heard, yeah, there is something spreading in China, and if I can predict what's going to happen with the oil prices, then I can, of course, adapt to that. I can tune my strategy of my company to actually, well, be prepared. We need to buy more oil. We need to maybe empty our reservoirs for oil because the price is getting down, and soon it will rise again. So I can make some money. Yeah, money is of course a big driver. Hopefully it won't stay that, but at the moment we are basically there. This is a quite nice cartoon. The Kyoto Aquarium has a flow chart of complicated romantic relationships between their penguins. I haven't been there, but yeah, once I'm there, I will be very interested to see how it works. So. Some data was tracked, how the penguins like each other, whether they are maybe cheating on their partners, stuff like that, and then depicted. I have no idea how they actually make sense of this, or how they actually use it. Maybe the people who are maintaining the aquarium can use it such that they are avoiding the fights between like some some love triangles. Yeah. Okay. This one is getting already interesting. The headline is basically enough. Facebook, what was it? April 2021. At some point, decided to block the web page of a French city, Biche. Why was that? Yeah, sounds like some swear word. What happened? Why did this happen?
Statistically, the combination of the letters in the word is mostly used in that way. So it just said it's probably also the swear word.
Exactly, yeah. So the Facebook has apparently a policy that the swear words should not be names of the website or of the Facebook sites or Facebook users, and then they are running an algorithm, because well, there are many of the websites. Then they are running an algorithm which is comparing the swear words and the names, and with some statistical evidence, with some probability, this algorithm said, okay, with more than 95% confidence, I can claim this website is violating the rules. This one is already quite old, and I don't know whether it really materialized. So how can we use the data? Google Maps was supposed to offer the most ecological, the most environmental friendly route for your car once you were trying to find the route for it. Did it happen? I don't know. Do you use Google Maps or anything? And I think it still offers like the fastest, and hard to say whether I can find my carbon footprint for this path or this path. Maybe it will happen.
Yeah, I think it provides also the shortest, like the lowest mileage.
Yeah.
However, I believe it doesn't take into account like anything like you go up or down or anything.
Yeah. Because it can also you go up or down is one option, and another option is of course it tells you about possible or the happening traffic jams. So that's not ecological, because then usually you end up running your engine stuck in some jam and not really doing anything. I also like this news. So this is getting quite personal, and the data, and it's about the data breaching. Of course, it sounds funny, yeah. The headline. So if you listen to Nickelback, be aware of this threat. But it points to another aspect, that data privacy. How do we encrypt the data? How can we cipher the data to make them inexposable to some third parties? I cannot name any specific countries in the world to be politically correct, but yeah, you can imagine that you don't want to share your data with anybody, but still we are doing it quite often. My beloved trend for the examples of how the world works with data. There are even some dates. There will be a couple of more headlines coming, and you might be even guessing which year is it taken from. Bitcoin price is over $30,000. Bitcoin price could go in the long-term horizon to $140,000. Bitcoin price over 40,000. In 3 days, the price is down by 1/5. The price, and this is now chronological. Yeah, so the value of Bitcoin is below $30,000. The value of Bitcoin is now up in just 7 days by 20%. And if you see the span of this news, that's really from 1 year. The span of this news is just 1 month. How to plot this? So how to visualize this data? Because I mean, you would agree with me that it's quite hard to keep track on these different newspaper headlines. So let's try plotting it. We are still below here $3,000. So the headline news were definitely from some future times compared to this graph. So Bitcoin, I think it started, or at least my trend starts in 2013, already quite some time ago. Well, it had some initial hype. Maybe people start to buy it, and then the price went down. So maybe if you are in August 2015, you might be quite sad that from $1,000 now the value of your valuable bitcoins of your investment is quite down. But there is no reason to be sad, because if you just waited 2 years. Look there, if you bought even for this price, $1,000, you are already 300% in plus just in 4 years. Yeah, the investments take some time. So this is the previous graph, and now we are extending it. Yeah, so this red line is showing where the previous graph ended. And we are now in, again, quite a volatile period. The price of the Bitcoin kept on increasing, 2017, 2018. So again, what if I caught this trend quite late and I bought the Bitcoin for $12,500 in just maybe half a year or almost a year? Well, we are back basically to the value where about $2,500. So again, should we be sad about this? Should we sell our bitcoins? Probably not, because it again would change, and yeah, then we can again think and reason what would happen to the people, to you, to us in different situations, whether we are happy that we bought Bitcoin for this price, and now the price is around again above $10,000. It's still a good investment. We don't need to be sad at all, because yeah, in 2021, and that's the year where the headlines which I showed you from the newspapers before were coming from. It got another big impulse, and now I don't remember what happened that year. I guess there were some regulations where got milder, so it got better acceptance with the merchants in the market. Good. So how will the
access to the market, like publicly, you can do publicly?
Yeah. Some.
And also, it's into pandemic time, so people don't travel. A lot of time they don't have the need for goods they usually have, so they have like excess money there. Also in the US, most of the people got like just free money. They can just check it for $1,000 to start the economy.
Okay. Well,
And
good.
they invest it.
Good guesses. You have some Bitcoin bought?
I used to.
Good. So, yeah, where are we So this is 2021. Where did we moved from there? Now this is slightly different graphics, but it shows basically the same data. This is almost end of 2021, so there is another small peak. It's interesting. I took this took this data from, well, some website. The website offered not only to show the price in the linear scale, but also the logarithmic scale, similar to what we saw with the Moore's law. And in the logarithmic scale, if you put it into this way, actually, if you get this data from some experiment, wouldn't you be really tempted to actually put a straight line to it and start predicting whether the price of Bitcoin in 2025 will be where it is now? Yeah, interesting question, but it at least shows that visualizing data in some different context can reveal at least some information. This is the price until 2023. There was some steep decline, but this is getting already not that visible. It should be until the maybe mid 2024. So there was, from this decline, there was again a recovery, and the recent one, so the value here is from the basically end of the year. This is maybe from last week, the snapshot. We got the US elections that and all this hype about it, which again skyrocketed the price. And if we would go back, this headline, which says in the long-term horizon the Bitcoin could climb up to $146,000. This is in 2021. So if you think about this for 1, 2, 3 years, you cannot see this going. But at the moment, well, we are quite attacking that. Yeah. This is not to persuade you, convince you to invest in Bitcoin. I don't invest in Bitcoin because I don't like the idea that it only drains the resources and it has actually no value. But it shows that there are different aspects in the data that will actually cause the change of some trend at some point. Yeah, this is the US elections. Somewhere here there will be a big jump when Elon Musk decided to buy invest $1 billion in Bitcoins. That also increased the value. It's quite hard to actually find out what happened that caused the trend, that caused what we see in the data values. Let's try another trend, and now it's up to you to guess what is it showing. I can reveal these are the time units, and okay, I will also reveal these are the days. Yeah, so day 1 to 33, and the value of the trend is 650. We again move in time, and we have now 100 days, 1 to 101, and our previous trend got reversed. Okay, and we have another part. So this is our previous trend. Yeah, this reached around 1,000, whatever the value is, and now in basically almost 1 year we got these peaks. What would you think? Where are these data coming from? And you can suspect the trends which I said that I liked in that I like to observe for this lecture. So one is Bitcoin, another one is some nice pandemic. What would you think these numbers are? This trend is. Yeah, Corona, COVID, and what exactly? Exactly. The number of the active COVID cases in Slovakia between March 2020, January 21st, we had the first mild wave, but then the second wave after the summer, so this is September 2020, hit us quite heavily. It's also interesting. So very similar trend, related data. Now it shows the days since first case on the horizontal axis, so basically some time, and we have the number of daily PCR cases. PCR was a method of testing for the COVID, antigen and PCR. Those were the two. And this is a MATLAB plot done by me. So I took some data from this National Center of Health Information, and I plotted it. The first graph which I got is this yellow thing. Why would you think we can see these sharp spikes, these peaks? Genius, exactly like that. The problem with this data used to be, I don't know whether you observed the news. Like I remember, at least for the first year, every day we were checking in the news how many new cases we got, and it was always the number of new cases was much higher on Monday, because many of the places for testing either didn't work on weekends, or the people decided to spend some time with the flu in their home, not that they were spending some other time outside, and they got tested on Monday. What we will see also in this course is how to reveal this kind of trend. So the blue curve here is trying to do some sort of averaging. I don't know whether you recall it. In our pandemic times, we were quite interested in 7 days median number of the active cases, and then there was this traffic light, whether something is aloft based on the number of the active cases based on the 7 days median. Yeah, so this blue curve is trying to do something similar, something which you might have already seen, or you will see in your technical means of automation class, when you will do some filtering. Did you do some filtering? Okay, you already did. So this is nothing else than just some applied filtering, and even Prime Minister was using the results of this filtering. What we can also guess from the data, this is again some COVID-19 data, but not from Slovakia this time from Germany. They had well, the first wave, actually similar to Slovakia, it was quite mild. Then the second wave was much tougher, and then it continued. So the top plot shows what? Shows number of the cases, while the bottom plot shows the more sad number, even the number of deaths, so number of people passed away. What can we first observe on these pictures if we compare them? What would you guess? Okay, that's strong. That's strong conclusion.
In the second way, because if we compare it, it's like much steeper in comparison to.
You mean here?
Yeah.
Okay.
I mean, like if we compare the quantity of deaths to quantity of cases.
Sure. Okay, but you are making a conclusion. So my conclusion is not everybody that got COVID dies, right? So, okay, good. Maybe let's see what do these two trends, at least in the beginning, have in common? The basic, how would you call it? The basic shape is common. Yeah. So these two variables, these two signals, as we would call them in the cybernetics, they are showing what is known as correlation. Yeah. They are correlated because if one signal is increasing, another signal is increasing. It's actually not at the same time. So we can say this system. Yeah, if we are observing this as two variables, this will be some sort of a dynamic system, some process. Yeah, there was one thing happening at the process which might have triggered. We don't know, because the correlation and causality are not the same thing. But the data is at least showing us that it triggered some response, at least qualitative. Yeah, okay. The numbers are not the same, but the thing that is happening is quite similar. Yes, and now we can go, for example, to this peak, which that's kind of some sort of a third wave in 2021, which is not that pronounced in the number of deaths. What do you think? What might have happened then? Very good. Yeah. Either it is vaccination. Yeah, we started with the vaccination. Well, really somewhere around here. Yeah, it's February 2021, and that's one thing. Another is some mutation of a virus. The virus might not have been that deadly because it evolves, and the variant of the virus was not that deadly, and also there might have been already some built-up resistance in the population, because, well, people could be infected by the COVID multiple times. Okay, let's go away from the COVID. Let's talk about some other data patterns. Anybody recognizes this picture? Okay, Patrick is nodding as well. Yeah. What does the picture say, or what do you know about the story? Yeah, the question, actual engineering problem was in the Second World War. What should we do to make more airplanes come back safe, or at least come back from some fight, from some battle? And what this graph shows, it actually shows a collection of data from several planes, and it shows where the plane was hit and still returned. So now the question is if we should reinforce the parts which are hit, or whether we should reinforce the parts which are not hit. What does the data say? What is the paradox in this picture?
I know in the correlation it's like showing us the survivorship bias, I believe, because those planes that were hit in these places actually returned home. So the more reinforced parts should be really those that are not hit.
Yes, yeah. The very simple and naive thought, no problem with naive thoughts, but like a sentimental thought, like all these poor airplanes, they are shot here, we should reinforce it there. But it would not happen, not help, because what actually made the airplane to not return is when the engine was shut. Yeah, if you think about it, when the pilot was shut. So that's actually exactly Adam described it. It's a survival bias. We are, or when this tiny narrow part was shot, so we need to enforce these parts. So this is one of the very early data-based decision making problems. How to make sense out of data and how to act accordingly such that we improve some performance. Another example of the data is well, not only this cardiogram, but many screening techniques in the medicine are producing this sort or some other sort of data. Like you would be scanned for some tumor, you would be scanned X-rayed for some sort of well, not only broken bones, but problems with the teeth and yeah, whatever you name it. Many interesting data points, and it's also growing. The number of data is growing. The number of skilled doctors who can read this data is actually not growing that much. So we need to do something about it. That's why Adriana is trying to find maybe her summer internship in the Siemens Healthineers who actually work on this type of problems, taking some data, or even maybe making this this is just a piece of paper and some ink pen was collecting the data. So first, to digitalize this is already a big step, and secondly, to find some trends, to reason what happened, when, how, what is the status of the patient, how should we, what is the diagnosis, how should we help the patient, what treatment. Another sort of visualization of data, quite similar to the plane example, is electricity generation compared to CO2 intensity per country. So now this is taking the amount of the electricity generated. This is interval 1 hour. Yeah, so each hour they would sample. This is France, you cannot see it well, it doesn't show our beamer. This is Germany, Poland, Slovakia is not here unfortunately, Italy, España, Belgium, Portugal, and so on. So each each hour, the electricity generation by the power plants in the country is measured, and what is also measured is the CO2 intensity. So how much CO2 is emitted to the atmosphere by this production. Tell me, what would you have observed? What would you have concluded from this plot? There are many conclusions you can do.
That the Polish production is the least effective in terms of producing CO2.
Why is that? What do you think?
They're using coal.
Exactly. Yeah, they have a lot of coal, and they have a lot of coal power plants.
And France, on the other hand, uses a lot of nuclear power, so that's why the nuclear emissions and
Yeah, very good. France is quite interesting because it shows what it doesn't matter how much power the country needs, it would still emit roughly the same amount of the CO2. Yeah, so this is the efficiency or environmental friendliness of the nuclear power plant. Poland is basically on the other end, but well, their electricity generation is even much narrower, so they are not that flexible. We could say, yeah. France is relatively flexible with the generation, but yeah, they are on the high end with the environmental friendliness. What about Germany? Germany has also some quite interesting trend. Don't know whether you would spot it. Yes, exactly. So when they have the but how to
I believe that Germany just turned off every nuclear plant they had. And they don't do them anymore.
Yes, yeah,
But
this
it's
is already.
2023.
Yeah. Okay, but let's now even forget this. This is Germany, and let's see whether you maybe it's only me who sees this, but whether you would agree that it sounds like there is a lot of happening along like this axis, yeah, which would have like what negative derivative, like what does it actually say? If I need to if I'm producing relatively small amount of energy, I have quite high CO2 emissions, but if I'm producing relatively high amount of energy or electricity, then my CO2 production, CO2 emission lowers. You see a similar situation, yeah? Okay, it's not only me. Perfect, and this is quite controversial, or you are thinking at first whether it makes sense, but exactly as Patricia was saying, this is the effect of the coal power plants running even when some renewables are not renewables. We might mean the solar power plant. So the high amount of the generation is actually coming during the day, during the peaks of when there is a good wind for wind turbines, clear day for the solar cells. So quite paradoxical in the beginning, but actually we can make sense out of this. And this brings us what you will try in your exercises. Brings us to different types of the visualization of the data. Yeah. So where we are starting is we collected some data, and even by using different plots of the data, we can already find some insights. I picked here 4 types of the data visualizations that are very common. Many of them you already know, and many of them we have already seen today. So the time series, this is what you have been seeing in the theory of automatic control. This is what we saw here today. Time series just means that whatever signal, whatever trend, whatever information data I got, I basically plot it with its corresponding time step on the horizontal axis, if I have the time stamps. Yeah. For example, we will get back to this plot, but there are no time stamps here. Yeah. So we actually don't know when is this point happening, when is this point exactly happening. Well, we just know something which you will call in the theory of automatic control to sampling interval. So we know that they are 1 hour apart. When we know the timestamp, so when something happened, we can reason about this. I remember some Rastio's data from Slovnaft, which were 15-minute data. So every 15 minutes there was one data point, and suddenly the data points started to double. So there were like 1, 2, 3, 4. And there was 1, 2, 3, 4. There were like for 1 hour in some period there was like double amount of the data. If I say this, and I'm not sure whether I illustrated it well, what would you think can cause this? Basically, it was saying that for 1 hour the sensor was giving us 2 different values. How can that happen? What are you whispering to Adam? Okay, the question is. I'm just now trying to reframe it in the form of a logical puzzles, like the twins were born, but they are 2 days older, or there is a 2-day difference in their birthdays. How is that possible? You know, this sort of puzzles or riddles. Okay, I wasn't illustrative enough. The problem which you may encounter with this, which we encountered, is just the curiosity, is the daylight saving shift. Yeah, summertime, wintertime. So at some point in time, the database, it was recording like when do we shift the time? It's like 2 a.m. 3 a.m. So it was 2 a.m. 2:15 a.m. 2:30 a.m. 2:45 a.m. 3 a.m. 2 a.m. because the time shifted, and now I don't know which direction is that, whether it's the winter to summer or summer to winter. Yeah. So there are some possible challenges that you might encounter. It's also well hard to observe the correlations. Well, let's go back to our to these examples. Yeah, these are the two time series plots, and a simple example because we have only two variables, and still it might be quite hard to observe that there is some correlation. If something happens, then something reacts to it. There is no deaths if there is no cases, and so on. Okay, so with this, scatter plots or correlation plots can help us. Let's try. This is very similar to that example with the power plants, but now we just took two variables, and we don't know. We are now losing the sense of time. Yeah, we don't know when these data points were collected. What we can say is, if we have one variable, we plot its value. We have also a corresponding pair, which were happening at the same time, or does not need to be at the same time. I don't want to complicate it, but whatever we know, at least we know when they are happening. What would you say about these two variables? What would you guess? What would you conclude? There is some correlation, and the correlation is positive or negative?
I'm sure if I answered correctly.
You answered correctly. You would have guessed that there is a
Positive. Positive correlation.
Yes. What does it mean? Yeah. So explain why you would think this is a positive correlation.
Consider one of the pair to be, for example, on the x axis. That the one on the y-axis is the function of the one on the x-axis. So we can see that if we somehow just try to approximate it with, for example, with our curve or line, the slope of it have the positive.
It's a positive slope, or you might say the same things in a different words, like, okay, it appears. Well, there is some sort of a mean, a very common situation, and if the variable which is plotted on the horizontal axis is increasing, what will the other variable do? The other variable, it seems that if we move to the right, then we are also moving up, which means that if this variable increases, then also this one increases. Yeah. The case of the Germany was actually an example of a negative correlation. If, for example, here we have some nominal, some mean case. So if we are generating more power, then we are emitting less CO2. Another interesting observation here is that it's seems to be quite likely, it's quite probable for these two variables to actually have a certain value, certain very frequently appearing combination, and this plot is already done in a such way, we will call it centering, that we will remove these values. So we actually would like take the axis and move the origin into the place where this most common value, the mean, is taking place. Why is it? Because then we can even easier can see the positive correlations, right? If I increase the value on the horizontal axis by 2, then the value on the vertical axis is increasing by 10. Yeah, it's much harder. Much harder to observe in these absolute numbers. Yeah, what does it mean? 600 grams CO2 equivalent. What does it mean? Is it big? Is it small? Here we can. Here we can directly see. Okay, these points here would represent positive deviation from the mean, and these points here would represent negative deviation because their values are actually negative. So it's not only visualization in terms of how do I plot the graph, also how do I transform my variables. We have already seen the logarithmic example with the Bitcoin price. Okay, we have seen this. Another interesting one, which is already kind of suggested in this plot with the colors, is are the histograms. Histograms, you know, you've seen, right? It's when we are trying to show what? When we are trying to represent that there is some density in certain regions, certain parts of the data. So here we are representing that there is a certain similar values in the region which is now plotted in red. Don't know how much visible is that, but for example the blue color is now representing here an interesting thing. It actually represents all the points with a certain distance from the mean. So it's trying to show us, well, either outliers or some values that are much less likely. Yeah, also for the Germany, it's much less likely to produce this amount of electricity with this CO2 intensity emission. It's much more likely to be somewhere in this cloud. We can also see it in, for example, in Poland. These points are much less likely. Here it's much denser, and we can visualize it with these kind of histograms. So this is a split between, this is a scatter or correlation plot, which on its own is showing actually almost no correlation between the data. Why would it be almost no correlation? Well, we cannot really say. Let's do the test from before. If we increase slightly this variable, then what will happen most likely in the previous example? Yeah, if we increase the variable, we increase the value of the horizontal variable, then we would see that also the values of the vertical variable increase. Here we cannot really say that. Yeah, there are many increasing, many decreasing. No, don't. Okay, I thought you were getting lost. About the density of the points, here come the histograms. So histograms in the vertical variable, histogram in the horizontal variable. What are they trying to represent? Well, basically, histogram is trying to make sort of bins. It's really like a basket where we say, okay, in this in this basket in the middle all the values between, I don't know, minus 0.1 until plus 0.1 will fall. So give me a count how many dots we can see with this value. And this count is really like throwing a pebble, a stone, some ball in a column. Yeah, so there we get this representation where we can directly see some values are totally unlikely, some values we didn't observe, never happened, some values are more likely, and maybe this starts to look like the famous bell curve, like the Gaussian curve, which I hope you either saw. This one is a very nice example of that curve. So either I hope you saw it, or you will at least refresh your memories about it. Okay, let's get well, we can have several different combinations of the scatter plot. So we have the values of these of the two variables again plotted with a similar visualization about the density of the point. So red means that there is a very likely place for something to be happening, which brings me to the last one, the parity plots. This is maybe the less likely. I don't know whether you've seen the parity plots, but they are quite useful, because what we talk about before, all these plots, they have a slight problem, that I need to decide about the number of variables that I will plot. Yeah, here there are two variables represented with some sort of the number or the frequency of the values. I now plotted 3 dimensions. I hardly can plot more. So I always need to choose for the relatively small number of variables that I can visually represent. Of course, I can have more pictures, but that is also quite limited. So one thing is to have like one possibility is to actually plot the trend which I observed versus how my model, how my understanding of the data is predicting the trend. And this is what in principle parity plots do. This is a specific example of it. I'll try to decrypt it. It's actually brightness of pixels in 2 photographs that were taken just 4 hours apart. So there is a brightness of the photo in the numbers between 0 and 0.5. So whether it's white or whether there is a black color on the photo, and of course the same thing is here. So we are trying to plot the two variables which actually share the unit, but one is actual observation, and other might be either a prediction of that variable, or it might be a variable that we are again trying to get some correlation with. Now we also have some sort of a histogram. So the blue dots is where some value, some brightness of a pixel was observed, but it's not that likely. On on the other hand, the red one is where we have many data, many pixels. And if you are asking where is the red one is around here. And this shows so 2 photographs of the same object. Maybe if I took a photo of you in the beginning of lecture and at the end of the lecture, it would show what there are white walls and a lot of white color in the photo. So that would be represented here, and basically along this line y equals x, I can now try to see what are the similarities between the photo, because if I have a brightness 0.1, whatever that means in 1 pixel, then if I took a photo of the same situation, then this point would be lying around this line. Basically, what this plot is trying to show that these 2 photos are very, very similar, and it's just some noise or some little things that changed on the photo, that they are different in between them. You will do some experiments with the parity plots during the exercises. Okay, this one I'm not going to talk about today. I will just finish it now. Ask you for any questions that you might have, comments or anything. And if it's not the case, I would like you to say your opinion about how did you like the lecture. How do you like that I'm speaking in English? Whether you understand it. In the YouTube video post-process after the lecture, you will see the subtitles. You can even download the transcript if you want from the lecture, and which can help you that way.